The number of shells, okay, number of shells, K shell, L shell, M shell, so on and so forth. The number of shells will tell us the period an element belongs to, okay? And then the number of valence electrons. Valence electrons are simply the electrons in the outermost shell, like the last number here, 1. This is valence electron 1, valence electron 3 valence electrons for aluminium, 7 valence electrons for chlorine. Okay, so let's have a little background. Now the period, I want us to be able to predict the period and group it belongs to. So if we use the K element shell notation, okay, you have sodium of atomic number 11 is 281. So you see it has 3 numbers here. So the number of shells, it has 2 in the innermost shell, 8 in the next shell, and 1 is the outermost shell. So it has 3 shells or 3 numbers. So automatically sodium is in the 3rd period. Now the number of valence electrons, sodium has 1 outermost electron, so it's in group 1. For aluminium, aluminium has an atomic number of 13, remember? So it has 3 divisions, okay? So it has the 3 shells, 2 innermost electrons, 2 in the K shell, 8 in the L shell, and 3 in the M shell, so 283. So to know the period, remember the periods are the horizontal rows, right? So what period does aluminium belong to? Just look at the number of shells. It has 3 shells, K shell, L shell, M shell. So aluminium is period 3 and group 3 because that's 3 in the outermost electron. So let's look at chlorine. Now chlorine has 287. So the number of shells, it has 3 shells. So chlorine also belongs to period 3. And then what group does it belong to? The number of valence electrons, so group 7. We need to understand this basic key concepts before we dive into the properties of atomic radius, electron affinity, ionization energy, so on and so forth. We need to understand its basic concepts, this background knowledge. So what is nuclear charge? Nuclear charge is basically the number of protons in the atom or species, okay? Nuclear charge, number of protons or atomic number, okay? Now, what is shielding or screening effect? Shielding effect is the ability of the innermost electrons, the inner electrons, to block the attraction that the positively charged nucleus has for the outer electrons. Remember, the nucleus is positively charged, so the electrons shield it off, okay? So what do we mean by, now, we also need to talk about effective or the net nuclear charge, okay? So the effective or net nuclear charge, that's Z subscript F. Okay, this EFF is for effective. So the net nuclear charge is basically the nuclear charge minus the shielding electrons. How many shielding electrons do we have? So let's look at these 2 elements, sodium and chlorine. Let's start with sodium. You know, sodium has a nuclear charge. That's number of protons. Remember we said nuclear charge? Nuclear charge is number of protons in the atom or species. So sodium has a nuclear charge of 11. You have to agree with me. 11 protons right there in the nucleus. Okay. So the effective nuclear charge is the nuclear charge, which is 11, minus the shielding electrons. What do we mean by shielding electrons? Shielding electrons are simply the electrons that are not in the outermost shell. So for sodium, just count 2 in the innermost shell. 2 plus 8. That's it. 1, 2, and then 8. So 2 plus 8 is going to give you 10. So we only have 1 valence electron. So 11 minus 10 will give you plus 1. Now for chlorine, we have 2, 8, 7, right? So we have 2 plus 8. 2 plus 8 is 10. Those are the shielding electrons. So S is 10. While we have 7 valence electrons. So 2, 8, making 10. So the nuclear charge, which is 17, minus the shielding electrons gives you plus 7. So chlorine has a stronger net charge. Guys, so if you notice, sodium and chlorine are in the same period, okay? They have 3 shells each. Shell 2, 8, 1. For chlorine, 2, 8, 7. You have to agree. So they are in the same period, 3. They belong to the 3rd period, okay? But different groups. This one is group 1. Sodium is a group 1 or alkali element, while chlorine is a group 7 or halogen, belong to the group of halogens. Now, but you see that the shell of chlorine seems to be smaller in size than that of sodium because of that charge. The nuclear charge is pulling the electron cloud closer, making it have a smaller radius. Alright, so lastly, I want to explain this footnote. The more the electron shells, the greater is the shielding effect. Okay, now you can see across the period from left to right, this is period 3, sodium is in group 1, chlorine is in group 7, but they are in the same horizontal period. They have the same number of electron shells, 3, 3. But if you go down the group 1, the shells are increasing. So the more the electron shells, the greater is the shielding effect. So we have sodium, I think lithium, sodium, potassium, and cesium. So as you're going down the group, the shielding effect is getting greater because the electrons, the shells are increasing. Similarly for chlorine, all right?